Okay, so yesterday in 4.7, we talked about inverse sine function. Remember inverse functions. General rule of inverse functions is they switch the input and output, right? X's and Y's switch. So thus up above it said the answer to an inverse sine problem is an angle. Normally in sine, you put in the angle, you get out a number from our chart. I forgot to fill in the chart. Okay. However, with inverses, we put in a number from the chart and we get out an angle. That's the general rule of thumb there. Okay. Same is true of cosine and tangent, obviously. Okay. Notation-wise, you still have the same options. Cosine inverse, so with a -1 power, or arc cosine. Tangent inverse with a -1 power, or arc tan. Okay, so if you start looking at the homework, you'll see some arcs in there. Don't let them freak you out. It's the same thing as saying inverse. Now, some domain and range issues, or information. Inverse cosine function, so now we're talking cosine, has a domain of -1 to 1. So just like sine, your input is the same options, -1 to 1. The range is different. It has a range of 0 to pi. Where is 0 to pi on the unit circle? 0 to pi on the unit circle is
0 to 180.
Okay, 0 to 180, quadrants 1 and 2. If you flip, dang it, I gotta remember to go the other way now. Got it in the middle. If you flip over here, again, this backside is my range values, yes? So now 0 to 180, that's where my cosine options are. Okay, that's your cosine options. You won't have answers in quadrants 3 or 4 there. Inverse tangent. Okay, inverse tangent is different in that it has a domain of negative infinity and positive infinity. You don't have to check your domain on inverse tangent. Anything goes. The range is -pi/2 to +pi/2, which is very similar to sine. The difference, if you go back and look at sine inverse range versus tangent inverse range, there are parentheses versus brackets, right? And so when you go and look here on your back of your page, okay, it still goes -pi/2 to +pi/2. So that's still our, whoops, -90 degrees to +90 degrees. The difference is, instead of having the -pi/2 and pi/2 showing, I have x's there. X is indicating it's all the way up to that value, just it technically cannot equal that value. Okay? Eventually you'll learn that there are asymptotes on that graph at -pi/2 and +pi/2. Okay? When we start graphing them. So, so still quadrants 1 and 2, you just can't have the endpoints. Okay, so there's your information. We've got a few practice. Now, realize these are going to be very similar to yesterday's, aren't they? A few tweaks along the way, but similar idea. Now we're going to jump right into. Okay, cosine inverse of -√2/2. And obviously note it says we are back to without a calculator. Anytime it asks you for exact value, you leave it in terms of square roots or whatnot. You don't give me decimal answers. Okay? So, cosine inverse of -√2/2. I'm going to drop the negative for a moment in my brain. And I'm going to ask myself, I just want to pair up cosine and √2/2. You guys with around 45 degrees? Now, of course, we're going to tweak that, though, and we're going to say pi/4. Okay? Same thing, I know. So, in quadrant 1, it's pi/4, yes? However, we're being asked about negative. Okay? Now, time out. What should I probably have checked before we started this problem? Is this a good domain value? Negative square root of 2 divided by 2. Well, I know square root of 2 to be about 1.4. Half of 1.4 is less than 1, right? So that's within the domain of negative 1 to 1. Okay, sorry. And here's the deal. If it's a number on that chart, is it probably good? It is, okay? As soon as I see square root of 2 over 2, that pops up, oh, that's one of my values over there. Even if I don't know where it is, that I know that's one of my values over there, don't I? Okay? So, we know, what we know here is that the cosine of pi over 4 is equal to square root of 2 over 2. That's kind of the information that my brain is thinking. So we want to know at what angle does cosine equal negative square root of 2 over 2? I have to disagree. Okay, now, negative pi over 4 would have worked great for sine inverse. But where is negative pi over 4 on the graph? It is in quadrant 4. I'm getting ready to erase that. What quadrants am I supposed to be in? If you flip back to the back side, you'll see my only options are to be in quadrants 1 and 2. That means quadrants 3 and 4 are off limits because I'm talking about cosine inverse. Okay? This is where cosine is a little bit more difficult. With this in mind, now, that means my negative values are going to be in quadrant 2. And is it true that cosine is negative in quadrant 2? Yeah, because that's, you guys know the drill of what I'm going to say, yes? Probably tired of me saying it. All students take calculus. That is, cosine is negative there. So what you're asking yourself is, what is the equivalent angle in quadrant 2? In other words, this one was up pi over 4 from the x-axis. I want the equivalent angle over here that is up pi over 4. 3 pi over 4? And I'll be honest, if you look at the unit circle, you can pretty much just look for what is the pi over 4 angle in that quadrant. Okay? You can also do the idea of, we're going to have to do 4 pi over 4 minus, and if I want that distance to be pi over 4, what is 4 pi over 4 minus pi over 4? And that gives me 3 pi over 4. Now, I just wrote that in orange. Can you guys see that? Sorry, I try to avoid. The orange is bright, but I don't know that it always shows up quite as well from the back. So I try not to use it too much, other than like a highlighter type thing. Okay, is that an appropriate range value now? It is, because it's between 0 and pi. Okay?
Is it negative?
Nope. And that's again where the trick comes in, yes? We so want, because it's a negative value, number value here, we want to say a negative angle. But it's not. You're not going to have any negative angle answers on cosine. Okay? It's always going to be something between 0 and positive 1 pi. So it's always going to be a positive value. Okay? Ready to try the next one? Tangent inverse of square root of 3. I'm going to remember this time. Check my domain. What do you think about the domain? We're an inverse tangent. What's my domain options? Anything. And here's my other thing. Again, square root of 3. Is that for my chart? I recognize that as one of my chart values. So that's always a good sign. Okay? So, at what angle does tangent equal square root of 3? At what angle does tangent equal square root of 3? 60 degrees or pi over 3? Okay. There's no negative, so there's no trick here. It's just pi over 3. Is that an appropriate range value? Yeah, because range for here is quadrants 1 and 4. Okay? And again, you were just asking yourself, tangent of what angle equals square root of 3? That's what you're asking yourself. Okay. Ready for C? That was your introduction, your easy part for today. C. Cosine inverse of cosine of negative 1.1. Okay, we talked yesterday. When you see multiple parentheses, you've been trained to start the inside, yes? Now, cosine of negative 1.1. What is this negative 1.1? Because this is cosine. This is not inverse. This is cosine. Cosine of negative 1.1. Negative 1.1 is supposed to be some type of angle. Okay? Is that something we know on our chart? No. And technically, we're supposed to be in a exact value non-calculator section. Okay. Go back to the concept from yesterday, though. Which concept yesterday that I'm trying to get you guys to think about is we had 2 of them, if I recall, where we did sine inverse of sine, yes? On part D from yesterday, sine inverse of sine, they basically undid each other, and we ended up with pi over 3, yes? And this one worked to give us that exact answer because pi over 3 is in the range of sine inverse. So when they undid each other, it just gave us the same answer back. Okay? Now, over here, sine inverse of sine, it didn't give us the exact answer back, did it? And this had to do with 5 pi over 6 is not in the sine inverse range. So we had to come up with equivalent angles. Okay? So again, this one takes a little bit more thinking. Now, the nice part about these is at least they gave us angles we could work with. Well, we're going to have to reason this one out because they didn't give me an angle I could work with. And so, cosine of negative 1.1. Well, the answer to cosine of negative 1.1, the answer to this is some kind of angle, yes? Do we know what angle? We don't know what angle, do we? Okay. Trying to think how I want to explain this. Easiest way to do this is a visual, but I'm still trying to think. I always have to pause and think. How do I want to explain this one? When we talk about negative 1.1, okay? Remember, we're talking in terms of radians here, yes? Where is negative 1.1 going to be? Okay, a little bit past 1, but in the negative direction, yes?
Yeah.
Now, think in terms, we're talking radians here, okay? Unless there's a degree symbol, you're talking radians. So with that in mind, think about it. This is 0, yes? What do we know? Now, we have to technically think negative, but these halfway points are technically pi over 2. What is pi over 2 as a number?
1.57.
1.57, yes? Are you seeing where I'm thinking of this? Because I'm trying to get you to think that, okay, yes, we think of this as pi over 2, but it's also 1.57. Just like pi is, well, yes, it's pi, it's also carries the value of 3.14, yes? Okay, now, and we can keep going, but here's what I need you to think. Negative 1.1. Well, first of all, negative goes down. How far am I going to go to get to negative 1.1? Keep in mind, if we're going negative, what is this? This is negative pi over 2, which is going to be negative 1.57. Okay, so it's going to be past 0 before you get to negative 1.57. Does that make sense? So I don't know exactly where, but negative 1.1 is going to be somewhere in there. Okay. Now, cosine inverse, we're going to undo that. But here's the deal. Where are my answers supposed to be for cosine inverse? Between 0 to pi. So I need my answers to be up there. Okay? Now, the other thing to think about, this cosine of negative 1.1. Down here in quadrant 4, does it carry a positive or negative value? The value of this cosine of negative 1.1 is going to carry a positive value. So when we go to cosine inverse, we need the positive quadrant. Where's the positive quadrant? That's going to be up here in quadrant 1. A negative 1.1 down here is equivalent to what up here? In other words, going down 1.1 from the x-axis is equivalent to going how far? Up 1.1? You see where I'm going with that? This was going down 1.1. The same reference angle, okay? That's what we're trying to get, is the same reference angle. Since I need to be in the positive quadrant, we're going to be at positive 1.1. If we needed 1.1 over here, we'd be seeing, okay, how far is it up from 3.14? All of this to say, and I kind of put my work where my answer is going to be, that when these undo each other, the only difference is that I need to land in a positive quadrant because this is a positive cosine value down here. So my negative 1.1 turns and becomes positive 1.1. Okay? Again, kind of like part E above. So I'm going to say similar to part E above. The problem is we didn't have that angle to work with. And so it's me trying to get you guys to follow the reasoning. Do we see it a little bit? A teeny bit? It's a stretch, I know. Okay, it's a work in progress there. Okay, I would say be more concerned of could you figure it out if you had an actual angle. Okay, but this is extending the concept here. Okay. Okay. Unless there's specific questions, let's try D. I guess I did have written down in here. I wrote same cosine, but in the interval 0 to pi. That was the key thing. Okay, so like when we looked at this, we had to have the same cosine value, but we had to make sure we were in the 0 to pi. Negative 1.1 was not. Okay? Okay. Change mindsets. D. Tangent inverse of 0. We're throwing a 0 out. What's going to have to be true if we're throwing 0 in the mix? Where do zeros happen? On your various quadrants, your quadrantal angles. In other words, keep in mind, this is not an angle, right? This is a number value. We don't have zeros on that chart over there, do we? Because our zeros happen on our quadrantal angles. So I can narrow this problem down to one of 4 answers. 0, if I go degrees, 90, 180, or 270. Actually, I can narrow it down even less because those aren't even really options, are all options, are they? But we want to know at what angle does tangent equal 0? That's what you're asking yourself. Tangent of some angle equals 0. So tangent of what angle equals 0? How do we do tangent? Okay, you remember that from the other day? Tangent is y over x. Well, if tangent equals y over x and tangent equals 0, what do we know about y over x? Okay, y is equal to 0, x is equal to 1 or maybe negative 1. But the important part is that if tangent is 0, y has to be 0, yes? Okay. Where on here does y equal 0? At what angles? Okay. Is 0 an option?
Oh, wait.
In other words, think ordered pairs here, yes? When is the y value 0? We're here, 1, 0, or negative 1, 0, yes? Because we want x, y. Now, what's your brain have to eliminate right now?
Negative 1, 0, because it's not relatively range.
Okay, where are we allowed to have answers? Negative pi over 2 to positive pi over 2. Anything on the left side, quadrants 2 and 3, are not part of our range values. So which one has to be our answer? 0. So tangent inverse of 0 is 0. Now keep in mind that 0 is an angle. The other 0 was just a number. I know, a little confusing with 0 and 0 there, but it's all about the reasoning. Okay, one more. Cosine inverse of negative 1. Didn't really talk. Is this an appropriate domain? Yeah, because cosine domain is negative 1 to 1, right? Okay, so now cosines and negative 1s. Do we have negative 1s on that? Do we have 1s on that chart in terms of cosine? Only 1s on that chart are for 45 degrees, and those are tangents. Cosine 1s don't happen on that chart. Cosine 1s happen at your quadrantals again. So my answer is either 0, 90, 180, or 270, but put those in radians. Okay, so again, it's cosine of what angle equals negative 1. Well, where's cosine negative 1? At pi, because keep in mind, in the ordered pair here would be left 1, up or down 0, And what do we know about an ordered pair? It's xy, but it's also cosine sine. We're looking for where cosine is -1. So that just happened at pi. Is that an appropriate answer?
No.
What are my cosine inverse outputs? 0 to pi.
Oh.
So is that an option? Yeah, pi is included. So 0 to pi.
But isn't it not on the...
Cosine inverse is the top two quadrants.
Okay. Oh.
Cosine inverse is the one that doesn't match
Okay.
the others.
Yes.
Okay, which one does not match? Cosine inverse is the one that's different.
Okay.
Okay, guys. I don't have any calculator examples here, but let me know if you run into issues. Second cosine and second sine, those are your cosine and sine inverses. Okay, similar to what we did with sine yesterday. Okay, page 378, 1 through 20, and 23 through 32. You've got some work time, right?
Is it okay if we don't show a lot of work?
Depends on the problem, but yeah. There's not always going to be work to show in this. Some of these, the work I'm showing is just us trying to reason it, and you may or may not need that work depending on the problem. Okay?
The first two I didn't show it.